Hello everyone. So in today's class, we'll start a new chapter. This is chapter 6, and we'll talk about normal distribution in this chapter. So in the last week, I told you that I'm going to give you a quiz this week. So I'm planning to give you a quiz on Thursday, and it will cover chapter 3 and chapter 5. Do you have any question?
No, sir.
Okay, thank you. Okay, so in the first section, we'll introduce the normally distributed variables. And before discussing normal distribution, first we'll discuss the basic properties of density curve. So property 1 is a density curve is always on or above the horizontal axis. So that's mean the density curve will be always on the horizontal axis or above the horizontal axis. So that's mean the y values will be always positive. Yeah. The density is always positive. So property 2, the total area under a density curve. So what is the total area under a density curve? If this is a density curve, then this is the total area under the density curve. And for a density curve, this total area will be always 1. Or your density curve could be like this, or it could be also like this. So whatever it is, the area under the curve is always 1. Otherwise, it will not be a density curve. And the total area under the curve represents the total probability. And we know that the total probability is 1. So that's why the area under the total area under the density curve is 1. Okay, so this is a density curve, and this is the total area under the density curve, and this is equal 1. Okay, so variables and their density curve. So for a variable with a density curve, if a variable has a density curve, the percentage of all possible observations of the variable that lie within any specified range. So for example, if if we consider the number of observations 2, 4, 6. So if we consider the observations 2, 4, 6, 10, 20, or maybe 30, 25, 60, 70. If this is our data set, and if x is our random variable, and if we can construct a density curve for this random variable, then the percentage of all possible observations of the variable that lie within any specified range. So for example, if we consider a range, maybe 10 to 65. And if we calculate the percentage of all the observations between 10 to 65. So what are the values between 10 to 65? 20. If they are inclusive, then 10, 20, 30, 25, and 60, right? So these are the values between 10 to 65. Now, if you calculate the percentage of this percentage will correspond to the area under the density curve. And if you construct a density curve for x, so if the density curve is like this, and if you take 10 and 65 here, so area under this curve between these two numbers, this area will be equal to the percentage of the numbers which are between 10 to 65. Yeah. So here the illustration of the previous effects. The percentage, so here we have the density curve, the percentage of all possible observations of the variable that lie to the left of C. So we have a number C, So if you calculate the percentage of all the observations which are left to this number, left to C, will be equal to the area left to C, area under this curve, and left to the value 6. So this area will be equal to the percentage of the observations which are less than C. And similarly, for this one, the percentage of all possible observations, above D will be equal to the area under this curve, under this density curve, to the right side of D. And similarly, here we have area between A and B. So that means all possible values of observations, all possible observations of the variable which are between A and B. Sorry, the percentage of all possible observations which are between A and B. Actually, the area represents the probability or the percentage. That's mean here we have area between A and B that represents the probability between A and B for variable X. This represents actually probability between A and B, and this represents probability X greater than equal D, and this represents probability X less than equal C. Okay, so actually that facts for any random variable and its density curve. So now we'll discuss about normally distributed variable. This is a specific random variable, and this is a particular random variable, and which is normal random variable, and we'll discuss about the distribution of normal random variable. So a variable is said to be normally distributed variable. So a variable will be called a normally distributed variable, or to have a normal distribution if its distribution has the shape of normal curve. So we already know the shape of normal curve, right? The shape of normal curve is bell-shaped, right? Is like this. It's symmetric and bell-shaped. So if a distribution has if a variable has this type of distribution, then we'll say that the variable is normally distributed. So here we have an example: frequency and relative frequency distribution for heights. So this is the frequency and relative frequency distribution for height. Then heights are between 56 to 6 inches to 74 inches. So these are the possible values. And we have the frequency and relative frequency. So the relative frequency, actually this represents the percentage or probability. Okay. So now if you construct the histogram for this one, then you can see that this histogram is bell-shaped, right? The shape of the histogram is like this. So that's mean this is the shape, the distribution of this random variable, the shape of the distribution of this random variable is similar to the shape of the normal curve, right? Is the normal curve. So that's why this variable is normally distributed. And the mean for this one will be the mean for variable X will be the mean of the distribution. And here the mean is 64.4 and standard deviation is 2.4. And normal distribution is denoted by, if X is random variable, then we can write normal, n means normal distribution, with mean mu and variance sigma square. So we use this notation to represent normal distribution. X tilde, you can say this is TLD tilde. So normally distributed with mean mu and variance. So the first number, if you have two numbers, for example, if you have two numbers like this, so here the mean is, or you can consider, for example, if the mean is 25 and variance is maybe 16, then we can, this number represents mu and this number represents sigma square, the variance. But some book also use a different notation. Different notation means some textbook also use this notation, mu sigma. Instead of variance, they use standard deviation. The first number represents the mu, mean, and the second number represents sigma. If it is sigma, then it is standard deviation. Yeah, so you should know these two different representation of the, or two different notation of the normal distribution. Okay, so normally distributed variables and normal curve areas. So for a normally distributed variable, the percentage of, it actually is same for the density curve, general density curve. The percentage of all possible observations that lie within any specified range, this is equal to the corresponding area under its associated normal curve. So it's same as the density curve. Okay, so a standard normal distribution. So what is a standard normal distribution? So we know that we know the normal distribution, but what is a standard normal distribution? So in normal distribution, the representation is, or the notation is, mu sigma square. So what is a standard normal distribution? We already know how to standardize a random variable, right? If x is a random variable with mean mu and variance sigma square, then the standardization is x minus mu over sigma. So what we are doing here, we are subtracting the mean from each observation, then we are dividing with the standard deviation. So we are subtracting with the mean, that's mean we are making the mean 0, right? So previously the mean was mu, now I'm subtracting mu from x. So when x equals to mu, the mean, then z will be mu minus mu over sigma, right? Then it will be 0. So that's mean for a standard normal distribution, the mean is always 0. When you standardize a random variable, the mean will be 0 because you are subtracting the mean, right, from each observation. That's mean from the mean value you are subtracting mean, and that's mean mu minus mu is 0. So the mean for the standard normal variable will be 0. Okay, and the one standard deviation above from the mean will be 1 for a standard normal distribution. Previously it was mu plus sigma. This number was mu plus sigma. Okay, so let me show it. Okay. So this is x, this is mu, and for example, this is our distribution density curve. So this one will be 1 standard deviation mu plus sigma, 2 standard deviation mu plus 2 sigma, and 1 standard deviation below the mean, and 2 standard deviation below the mean means mu minus 2 sigma. Similarly, we can also consider 3 standard deviation away, 4 standard deviation away, or 5 standard deviation away from the mean. Okay, now what happened to the standard normal distribution? This is x minus mu over sigma. So when x is equal mu plus, when x is mu, z will be mu minus mu over sigma. That's means 0. When x is mu plus sigma, z will be mu plus sigma minus mu divided by sigma. So if you simplify this one, mu minus mu will be cancelled out, and sigma divided by sigma, it will be 1. Okay, and when x equals to mu minus sigma, then z will be mu minus sigma minus mu divided by sigma, which is -1. This equal -1. Okay. So now you can see that for a standard normal distribution, when x is mu is becoming 0. When x is mu plus sigma is becoming 1. what is mu plus sigma? This value, this x value is one standard deviation away from the mean. And now you can see the z score is 1. Actually, the z score is represents the value. So how many standard deviation away from the mean? That's what the z score represents. Actually, this value is one standard deviation away from the mean. That's why we have 1 corresponding to this value. And similarly, if you calculate this one, you will find 2. So this value will become 2. So that's mean this is 2 standard deviation away from the mean. So the z score represents how many standard deviation away from the mean is that value. So similarly, this is mu minus sigma. So this is 1 standard deviation below from the mean. So that's why it will become -1. So negative means it is below from the mean, below the mean, and positive means it is above the mean. And for corresponding to this one, you will find -2. And that's mean this value is 2 standard deviation below the mean. Do you have any question? Oh yeah, sure. I'll try to slow down. Yeah. Thank you. Yes, we'll go over actually more example. Yeah. Yeah, thank you. Okay, so now carefully look at this picture. So the first one in the first one, the above one, top one, how many density curve we have? We have 3 density curve, right? The green one, red one, and orange one, right? We have 3 density curve. Yeah. So the first one, the mean mu is -2 and sigma is 1. And in the second one, mu is 3 and sigma is half. This is the first one and this is the second one. And in the third one, we have mu is 9 and sigma is 2. So we have 3 different normal distribution. So we have 3 different normal distribution. So when you standardize, after standardizing, this normal distribution will correspond to this one. This one will also correspond to this one. This one will also correspond to this one. So that's mean all normal distribution are corresponding to the same normal distribution, which is called standard normal distribution. Okay, so why the standard normal distribution, standardizing the normal distribution is important? This is important because when you will be calculating the formula from the normal distribution, so this density curve, it has a function which can be written as f of x. I'm not going to discuss about the density function that much. I'm just trying to give you the idea. So this density function is 1 over 2 pi, I think 2 pi sigma or sigma square, yeah, e to the power minus 1 over 2 sigma square times x minus mu square. Okay, so you do not actually need to know this function, but just look at this function. This function is very complicated function. So if you have already taken the calculus class, then you know that how to find the area under curve for a specific function, right? You have to integrate, right? You have to use the integral. So this is a very complex function. Exponential and power is 1 over 2 sigma square x minus mu square. So if you want to integrate this one every time, and yeah, it's very time consuming, and sometimes you will not be able to integrate this one. So instead of, so if you want to directly calculate the probability from the density function, So instead of doing this, we standardize all the normal distribution to a standard normal distribution. And for the standard normal distribution, all the areas or all the probabilities are known. So if you heard about the normal chart, or I can just show you. Yeah, we have actually this type of chart. So here we have all the z-score. That's mean all the standardized values and their corresponding probability. So if you can transform all normal distribution to standard normal distribution, after transforming, it will be easier to find the probability using this chart, or you can also use calculator. So that's why actually we need to standardize the normal distribution. Okay. Okay, now you can see that. So the formula is x is equal x minus mu over sigma. So the mu for this one was -2. So the mean was -2. That's why this -2 will actually become, when x is -2, so x minus mu, this is become 0. The mean will become 0 for standard after a standardization. And similarly, if you standardize this one, the mean will become 0. And similarly, if you standardize this one, the mean was previously 9, now it will become 0. So we had 3 different normal distributions. Now after standardizing, they become just a single normal distribution, and you can use the table to find the probability or to calculate the probability, and then our life will be easier. Okay, no, you will always, actually you do not have to find the original value directly. First you will standardize, and you will calculate the probability or the values from the standardized normal distribution. After that, you can transform it using this formula, z equals to x minus mu over sigma. Yeah, we'll go over some example and you'll see it. Okay, so this is also standardizing normal distribution. So it was our original normal distribution x, and this is after standardization. This is x minus mu over sigma. You can see here the mean became 0. Then this is the one standard deviation above the mean, so it became 1. This one became 2. This one became 3, and you can see that the area for the normal distribution, all the areas are, all the probabilities or all the observations between -3 and 3. And this is true for most of the normal distribution if there is no outliers. Then most of the observations will be between, after standardizing, most of the observations will be between -3 and 3. And you already know that almost 99.97% observation will be between -3 and 3 standard deviation. Okay, finding percentage for a normally distributed variable from areas under a standard normal curve. So this is our normal curve, and this is our standard normal curve. So if you want to find the area between two numbers, so we want to find the area between A and B. So how can we find this area? The first thing is, first you need to convert it to a standard normal distribution. So that's mean you need to first convert this number using this formula, x minus mu over sigma. So for x, it was A. In the standard normal curve, this value will be x minus mu. That's mean A minus mu over sigma. It will become A minus mu over sigma, right? So corresponding to this value on the standard normal curve, it will be A minus mu over sigma. And similarly, we need to convert this one, it will become B minus mu over sigma. Now we have to look at these two values on the z chart, and you will find the probability. Okay, so here we have examples. We'll go over couple of examples. The first one is a curve has area 0.467 to the left of 39. So here actually this is a general density curve. They didn't say that this is normal density curve. Okay, a curve has area 0.467 to the left of 39. So let's consider a curve. This curve could be any curve. So let's consider this density curve for this one. And it has area left to the 39. So let's say 39 is somewhere here. And area 0.731 to the right of 39. So it's saying that this area is 0.467 and this area is 0.731, and this is a curve. This is just a curve. They didn't say that this is a density curve. They said this is a curve. So they gave a curve and they said the area on the left side of 39 is 0.467 and the area on the right side of 39 is 0.731. Could this curve be a density curve for some variable? Explain your answer. What do you think? Is it a density curve or not? Yes, the answer will be no, right? The area is greater than 1. But we know that, yeah, thank you. Yeah, you got it. So the area, we know that the total area under the curve is 1. And here the total area is greater than 1. So this is definitely not a density curve. So we have one more example. A curve has area 0.5 to the left of 123 and the area 0.378 to the right of 123. Let's consider another curve. Maybe this curve is like this. So we have 123. So 123 is somewhere here. So the area on the left side, this area is 0.5 and this area is 0.378. So is it a density curve? What do you think? Okay. So I just got one answer. You said yes. Okay. So many of you said yes. Okay. Okay. So I didn't get any no vote yet. Okay. So I just got one no. So 2 no. Okay. So actually I got only 2 no votes and most of the yes votes. So how about others? Okay, so what do we know about the total area under the density curve? So what is the total area under the density curve? 1, right? Yeah, total area 0.5 plus 0.378 is less than 1. Yeah, that's correct. It's less than 1. But we know that the total area under the density curve is 1. So that's mean this is not a density curve, right? This is not a density curve. Because we know that the total area under the density curve is 1. Since the total area under the density curve is less than 1, so it cannot be a density curve. So this is also not a density curve. Okay, we have one more example. A density curve has area 0.675 to the left of -37. So what is the area to the right of negative 37? So let's consider a density curve. So this is a density curve. Now they say they gave that this is a density curve. So total area is 1. So we have negative 37. And to the left of this negative 37, the area is 0.675. So this is the area on the left, to the left of negative 37. So what will be the area to the right of negative 37? Mm-hmm. 0.325, 0.325. Yeah. Yeah, you got it, right? Because total area is 1. So this part will be 1 minus 0.675. So that means 0.325. Yeah, that's correct answer. Yeah, thank you. Okay, and actually this is similar. So we are given that we have a density curve and the area to the right of 675, this is 675, and the area to the right upside is 0.012. Okay, so the density curve, it not necessarily it will look like this curve. I'm always drawing this type of curve, so you might think that, okay, so the density curve will always look like this. No, the density curve could be like this. It could be also like this. The density curve also could be like this. It could be also like this. The shape of the density curve could be like, could have any shape. So it not necessarily should be like this. It can take like any shape. It depends on the distribution actually. So since this area is 0.012 to the right of this one, and we know that this is a density curve, so area on the left will be then 1 minus 0.012. Yeah. That means 0.988. Yeah. Thank you so much. Yeah. Yeah, you're getting the correct answer. That's great. Okay. So I have already graded your quiz. So you can see your quiz grade now. And if you have any question about the quiz grade, please let me know. Yeah, if you have any question, please email me, yeah, so that I can answer your question. So examples, a density curve has area 0.34 to the left of 32. So let's consider a density curve. So this is a density curve. And the area to the left of 32. So we have 32 here, and we have two numbers actually. We have 32 and 67. So the area to the left of 32, this area is 0.34. And area to the right of 67 is 0.25. This area is 0.25. So now we need to find the area in between. So what is the area between these two numbers? Okay, so I'm getting different answers. So I got 0.45, 0.43, 0.41, 0.43, 0.41, 0.43. Okay, 0.41, 0.41. Yeah, now I'm getting 0.41, 0.41. Okay. Yeah. Yeah, I think it should be 0.41 because the total area is 1. So basically it will be 1 minus 0.34 minus 0.25. Yeah, that's I think, yeah, this is 0.41, I think. Yeah. Actually, you will need this idea. I'm showing these examples, the simple examples, so that you get used to this, because you will need this idea to find the probability from normal density curve. Okay, the next one is, given the mean of a random variable is 5. So we are given that the mean of a random. Okay, so when it will be said that the mean of a random variable, so that's mean this is the population mean, not the sample mean. This is not X bar. When they will give the sample mean, they will for sure mention it that the sample mean of the variable X or something. But if they just say that the mean of a random variable, so that's mean this is the population mean, mu. So mu is 5 and standard deviation sigma is 1. So we have to find the z-score when X is 4, when X is 4 and X is 7. So we know the formula, Z is equal X minus mu over sigma. So when X is 4, it will be 4 minus mu is 5 divided by 1. So this is -1. And similarly, the z-score corresponding to 7 is 7 minus 5 over 1. So which is 2. So now you can see that the mean was 5 and 4 is on the left side of 5, right? To the left side of 5. So that's why we have negative z-score, which is 1. And 4 is 1, standard deviation is 1, sigma is 1. So 4 is 1 standard deviation below the mean. So that's why we have -1. And similarly, 7 is 2 standard deviation above the mean. So that's why we have +2. Okay, so we have one more example from this section, and this is the last example for this section. So given the mean of a random variable is 50. So the mean of random variable is 50, mu is 50. Then standard deviation is 5, sigma is 5. Find the values of X. So find the values of X. So we have to find X when X is equal, when Z is equal 1.2. And find the X when z-score is equal -2.5. So how can we find the value of X? So we know that the z-score is equal X minus mu over sigma. So now we can write, if you multiply with sigma both sides, sigma here and multiply with sigma here, then sigma will be cancelled out. So we'll have actually sigma times z is equal X minus mu. So now if you isolate X, finally we'll have X is equal mu plus sigma times z. So that's mean this is equal mu plus sigma times the z-score. Mu is 50 plus sigma is 5 times 1.2. So it will be then 50 plus 6. So that's mean it will be 56. And similarly, the corresponding to this z-score, this is not 7. This is actually z. And this is actually z, not 7. Yeah. So when z-score is -2.5, then we know that mu plus sigma times z-score is equal 50 plus 5 times -2.5. So it will be then 50. This is negative, this is positive, so it will be negative and 12.5. So that's mean it will be then I think 37.5. Yeah, this is 37.5, the value of X. And here you can also see that 56 corresponding to 56, the z-score was 1.2. So that's why the z-score is positive, and you can see here it is 56, which is above the mean. And when z-score is negative, negative 2.5, we found 37.5, which is below the mean, below 50. Yeah, x is 56, and yeah, thank you. And x is 37.5. Okay, so do you have any question? Okay, thank you. So now we'll calculate the areas under the standard normal curve. Till now we discussed area under the curve, under the density curve. Now we'll discuss about the area under the standard normal curve. So here are some basic properties of the standard normal curve. Property 1 is the same property, the total area under the standard normal curve. Since standard normal curve is also a density curve, so the total area will be equal 1. Second property is the standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis. So that's mean it will approach to the horizontal axis, but it will never touch the horizontal axis. It will never touch the horizontal axis, and similar to this one. So it will go extend indefinitely, but it will never touch the horizontal axis. Third property is the standard normal curve is symmetric about 0. That's mean the mean is 0. So we have area on the right side, which is 0.5, and the area on the left side, which is also 0.5, because it is symmetric. The area on the left side of the mean will be equal to the area on the right side of the mean. Okay. Property 4 is almost all the area under the standard normal curve lies between -3 and 3. So though there are some area, but this area is very negligible, very small area. Most of the area will be between 3 and -3. So most of the area will be about 99.97% area will be between -3 and 3. So these are the basic properties of the standard normal distribution. So here we have the table for areas under the standard normal curve. So this is called Z table. So you will be using Z table to calculate to find the value of Z, or to find the probability corresponding to Z score. Okay, so here we have area to the left, area to the right, and area in between two number. So the area to the left of Z score, this is this shaded area, and the shape of the distribution is symmetric, bell-shaped. So this is the shape of the standard normal distribution, and this is the area to the right. So to calculate this area, actually we'll subtract the area to the left from 1, because this is symmetric. So this is symmetric. So that's mean if you subtract this area, the area to the left, then you will get from 1, then you will get this area, and this area represents actually this area. And shaded area, so how can we calculate this area? Okay, so if the Z table always give the area to the left, so the Z table, what we'll be using in this this course, will always give you the area to the left. So that's mean if you look at a specific Z score, for example, if you look at 1.2, that will give you the area on the left of this number. That will always give you this area. So if you look at the area for this number on the Z table, it will always give you this area, not the area on the right side. Okay, so now how can we calculate the area in between two numbers? So we have two z-score, this one and this one. So if you look at this one, it will give you the area to the left. That's mean this area, but we are not looking for this area, right? And if you look at this number, it will give you area to the left of z2. So that's mean we'll get this area. But we are interested about area between these two numbers. So now we have area of this shaded region and this unshaded region. So if you subtract this part from this one, that's mean the area corresponding to z2, if you subtract the area corresponding to z1 from the previous area, then you will get the area in between these two numbers, right? So that's why the shaded area is area to the left of z2 minus the area to the left of z1. So actually the basic idea is, first you will find the area for the largest number. z2 is the largest number right here. If you compare z1 and z2, this one is the largest number, right? First you will find the area corresponding to this number minus the area corresponding to this number, and that will give you the area in between these two numbers. Is it clear? Okay, actually we'll go over some example and it will be more clear to you. Okay, thank you. Actually, people do common mistake in calculating the area from a standard normal distribution. Okay, so there is another notation. This is called Z alpha, the Z subscript alpha. So this is called alpha, ALPHA. I think you know this one, right? Alpha, alpha, beta, gamma. Okay. So the symbol Z alpha is used to denote the z-score that has an area of alpha to its right under the standard normal curve. Actually, this notation means this is actually read as Z alpha. So what does this mean? This means area on the left side of this z-score, and this area is alpha. Z alpha represents a z-score, and this is this z-score, and the area on the right side of this z-score is alpha. So that's the meaning of this notation. So you can say Z sub alpha, or simply you can say Z alpha. So Z alpha means the z-score, and where the area on the right side of the z-score is alpha. Okay, so finding Z 0.025. So how can we find this value? So Z 0.025. So that's mean this is a z-score where the area on the right side of this Z is 0.25. So that's mean we want to find this value, this z-score, and where the area on the right side is 0.025. And similarly, here the second one is Z 0.05. So that's mean we want to find the z-score, the Z value, where the area on the right side of this is 0.05. Okay, so we'll come back to this slide later, because first you need to get used to with the Z table. And yeah. Okay, let's go over some example where we'll be using the Z table to find the probability. So according to a standard normal table, the area under the standard normal curve to the left of 2.56 is 0.925. So from the table, we found that below this number, area to the left of this number is 0.925. So without consulting a standard normal table or using technology, determine the area under the standard normal curve. Now you need to determine the area under a standard normal curve to the left of negative 2.56. So this is negative 2.56. Now we want to find this area. So without using any table and without using any technology, that's mean any calculator or computer, just using the given information to find the area to the left of negative 2.56. So what should be the area? So how do we calculate this area? Anyone?
Would you calculate the area of the 0.925 and the 2.56 and minus it? So you get the negative?
Okay, so for negative 2.56, so this is the area. Okay, I can just give you one more information. So we know that the standard normal distribution is symmetric, right? So this is symmetric. So that's mean the area on the right side of 2.56, this area will be equal to this area. Yeah, I think now you can find the area on the left side of negative 2.56, right? Yeah, you know that total area is 1. So it will be just 1 minus 0.925. Yeah, that's correct. Okay, so if you do 1 minus this one, you will get this area, right? The area on the right side of 2.56. And we know that this is symmetric. So this number and this number, they are same, but with opposite sign. So area on the right side of this one will be equal to the area on the left side of this one. So they are same. This area and this area are same. Yeah. So we'll use this idea to calculate the area here. Oh, this is not actually 0.75. Yeah. Yeah. Do not. Yeah. Be careful when you are typing your answer. Yeah. This is actually 0.075. Yeah. Not 0.75. Okay, so now we'll go over one more example. Determine the area under the standard normal curve that lies to the left of this number, this number, this number, this. Okay, so part A. Okay, so when you will be calculating the area from standard normal distribution, it's always better to draw the curve. Otherwise there is a chance of doing mistake. So z is equal 1.45. This is 0. So 1.45 should be somewhere here. So now we need to calculate the area to the left of this number. So area to the left means we need to find this area. Okay, so now I will show you how to use the z table. Okay. So this table is called z table, and this is for negative z-score. So the left column and the top row, this row and this column represents z-score. So this is negative 3. The first number is negative 3.6. That means this is negative 3.6. And when you are considering this one, the second digit, this row represents the second digit of z-score after the decimal point. After the decimal, the second digit of z-score is the top row, this row. The top row is the second digit after the decimal of z-score. So if you consider the first number and all this number inside the table, they are the area below, area to the left of the corresponding z-score. Okay, so for example, if you look at this area 0.002, actually this is the area to the left of -3.6, and the second digit is 0. So that's mean this is -3.6. So this area is 0.0002. Now if you look at this area, this is actually area left to the corresponding z-score is -3.3, and the second digit is 0.01. So that's mean this is -3.31. So this area is 0.005. And if you look at this area 0.0032, so that's mean this is actually area to the left of -2.7, and second digit is 3. So that's mean -2.73. And similarly, if you look at this number, this is the area to the left of -1.8, and second digit is 5. So that's mean -1.85. Similarly, if you look at this number, then this is the area to the left of -0.9, and second digit is 7. So that's mean -0.97. And similarly, if you look at this number, then this is the area to the left of -0.4, and the second digit is 4. That's mean -0.44. So now we'll find the area to the left of 1.45. So how can we calculate this area? And we have also the z table for the positive number. So this is the z table for the positive number, positive z-score. Okay, so since our z-score is here, okay, I'm sorry. Yeah, here. So this is positive. So we have to look at the z table for positive z-score. So this is 1.45. We need to find this area. So look at this table and 1.45. So where is 1.45? So we'll look at the z-score, not the probability. So 1.4 is this one, and second digit is 5. So that's mean this one. So the area is this one, 0.9265. So the area to the left of this number is 0.9265. Yes, that's correct. 0.9265. That's great. Thank you. Okay, the part B is, this is 2.56. So the middle value is 0. So this is 2.56. So we need to find the area to the left of this number, 2.56. So let's go to the z table. 2.5 is here, and second digit is 6. So that's mean here and here. So 0.9948. So the area is 0.9948. Okay, for this one, the area is 0.9948. And similarly, we'll find the area for -2.43. So part C is -2.43. Oh, I'm sorry. Yeah, it should be. So this is 0. Negative means on the left side of this number, -2.43. So we need to find this area. So now we have to look at the Z table where the Z score is negative. So negative 2.43. So negative 2.4. Where is negative 2.4? Negative 2.0. 1, 2, 3, 4. This stuff. And second digit is 3. So that's mean this one. So here and here. So this is the area. 0.0075. So the corresponding area will be then, this area will be then 0.0075. So is it clear how to find the area from the Z table? Or do you have any question? Okay, thank you. Actually, you should know this one, but in the exam, you may use calculator to find the area. Okay, thank you. So this example, determine the area under the standard normal curve that lies to the right side. So in the previous example, we calculated the area, or we found the area to the left side of the Z-score. Now we'll calculate the area to the right side of the Z-score. The first one is Z is equal negative 2.15. This is 0. This is negative 2.15. We need to find this area. So let's go to the negative Z table. So negative 2.15. 2.1 is here and 5 is here. So we'll go from here to here. So this is 0.0158. Oh, I'm sorry. Yeah. 0.0158. So this area is 0.0158, right? Is it correct or I did mistake? What do you think? Anyone?
Right.
This is correct answer or? Okay. So one student said it's wrong. Okay. How about others? Is it correct or wrong? It's wrong, right? Yeah, this is wrong. Yeah. So if I do mistake, that's fine. Because I'm not going to take the exam, right? It will not affect my grade. But if you do mistake, yeah, then it will be problem. So the area will be, that's correct, 1 minus 0.0158. Actually, when you look at this table, because it's always giving the area to the left. So that's mean when you look at this number, you will get the area to the left of this number. So that's mean you will get this area. So to find the area to the right, you have to subtract it from 1. So that will be 1 minus 0.0158. And similarly for part B, Z score is 1.36 and we have to find the area to the right. This is 0, so 1.36. So we have to find this area. So look at this number, look at 1.36. 1.3 is here and 6 is here. So 1.36 is 0.9131. So this is 0.91. So if you look at this number, you will get this area. This is 9131. So the area on the right will be then 1 minus 0.9131. Yeah, that's how we calculate the area from the standard normal curve. So now we'll calculate the area between two numbers. So part A, area between negative 1.23 and Z is equals to 1.23. So this is negative 1.23 and this is 1.23. So we have to find area between these two numbers. So if you look at negative 1.23, okay, Yeah, if you look at negative 1.23, then you will see that 1.2 is here and 3 is here. So it will be 0.1093. So this is 0.1093. So this area is 0.1093. And since this number and this number are same, so the area to the right will be also 0.1093. So the area between, okay, there is two ways. Since we have like same number, so that's why we do not need to look at the table again. But if you have two different number, then you have to also look at the table for this number. So for example, for part B, we do not have the same numbers, right? The first one is negative 2.16 and the second one is z is equals to 0. So you have to look at these two number. Okay, but here since they are same, negative and positive, and we know that this is symmetric, so the area to the left of negative number will be area to the right of, will be equal to the area to the right of the positive number. Yeah, and this area will be then 1 minus 0.1093 minus 0.1093. So this is the area between these two numbers. Yeah. Okay, so do you have any question? So do you want me to go over part B and C, or is it clear to you? Should I go over part B as well? Okay, sure. Yeah, because there are two different numbers. So actually it will be better if we go over this one. So this is, okay, part B is we have to find the area between z is equals to negative 2.16 and z is equal 0. So this is 0 and this is negative 2.16. We have to find the area between these two numbers. So from the table, if you look at negative 2.16, negative 2.16, this is negative 2.1 is here and 6 is here. So that's mean it will 0.0154, 0.0154. So this is 0.0154. So this area is 0.0154. Okay, so now if you look at 0, so what will be the area to the left of 0? So what is the area to the, this is 50%. Yeah, this is 50%, 0.5. Yeah, that's correct. Yeah, so this is 0.5. So if you look at this number, this area will be 0.5. So that's mean the area between negative 2.16 and 0 will be then 1 minus, this area will be then 1 minus, okay, so I'm writing here, this area will be then 1, sorry, not 1 minus, 0.5 minus 0.0154, right? So that will be the area. So the idea is when you will be calculating the area between two numbers, first look at this number, find the area, minus look at this number and find the area. So for 0, the area is 0.5. Area to the left is 0.5. And for negative 2.16, the area to the left is 0.0154. So if you subtract these two area, then you will find this is 6, this is 4, this is 8, and So 0.4846. The answer will be 0.4846. Yeah, that's correct. 0.4846. Okay, so this is the last example from this section. And also this is the last example for today. So complete the following table. So we have, okay, I will complete the first two, then you will complete the rest of them. The first one is z is equals to 0.25 and z is equals to z 0.2. So actually this is z alpha, z.25. This notation actually represents, if this is the normal curve, then this is 0.25. And the area on the right side, so this area represents the, always represents the area on the right side of z score. This area is 0.25. Now we have to find the value of corresponding z score. So here we have the area, we have to find the z score. So if you look at the table, so the value inside the table are areas, right? Are the probabilities. And this column represents the z score, and this row represents the second digit after the decimal point of the z score. Okay, so now we are given the area, we have to find the z score. So what was our area for the first one? 0.25, and the area on the right, right? So the 0.25, where is 0.25? This is 0.14, 0.15, 0.17, 0.23, 0.24. Actually, the 0.25, we do not have it clearly here, but it is between these two numbers. You can see here. This is 0.2483 and this is 0.2514. So 0.2483 and this number is 0.2514. So that's mean 0.25 is between these two numbers, right? Okay. Now we have to find the corresponding z score. This is negative 0.6. And what is the second digit for this one? Okay. So now we have 0.25 is in between these two, right? Because this number is 0.2483, this number is 0.2514. So the 0.25 is in between these two. So now how can we get the second digit for this one, for the z score? It could be 0.08 or 0.07. Okay. The one idea is you have to look at 0.25 is closest to which number? 0.25 is, if it is closest to 0.2514, then you will consider 0.07 as the second digit. If it is close to 0.2483, then you will consider this one as the second digit. Or you can just take the average of these two numbers. So the average of these two, 0.08 and 0.07, is I think 0.075. So that's mean the digits after 6 will be then 675. So the z score is negative 0.675. Okay, so corresponding to this one, the area on the left. So this is 0.25. So if you look at this area, then we get negative 0.675 for the area on the left, right? But we need to find the z score where the area is on the right. So since 0.25 and this 0.25, they are same. So this z score and this z score will be same with different sign, right? So that's why it will be actually positive 0.675. And similarly, now we'll calculate the z score for 0.20. So where is 0.20? 0.20, we'll find 0.20 here. So this is 0.2005. Can you see this number? And this is 0.1997. So that's mean 0.20 is between these two numbers, right? So that's mean the z-score will be the negative 0.8 and the average of these two numbers. So 0.05 and 0.04. So that's mean 0.045. So this z-score will be the negative 0.845. But we are looking at the area on the left, but we have to find the z-score where the area is on the right. So that's mean it will be then 0.84, positive 0.845. So the next number is z.15. That's mean the area on the right is 0.15. You have to find the z-score. So let's go to the z table and find the 0.15, the area 0.15. So where is 0.15? This is 0.149 and this is 15. So that's mean 0.15 is between these two numbers, right? This is 0.1492 and this is 0.1515. So that's mean the z-score will be then, this is -1 and this is 0.4 and 0.3. So the average of 0.404 and 0.03 will be then 0.035. So this z-score will be then negative 1.035. Okay, so it will be then 1.035. Similarly, we'll find the z-score for this one and this one. Okay, so we have 3 more minutes. Try to find the z-score for 0.025 and 0.01. Yeah, try to find the z-score for these two and let me know. Okay, so this is the z table. You can use this one. So find this value. Okay, so I'm just writing the value 0.025 and 0.01. Okay, so find 0.025 and z.01. So find these two values. Okay, so I'm saving your responses and I'll use these responses to give you some bonus points later.